Hello everybody and welcome back. We are starting off this week's topic by discussing array lists. Let's imagine for a second that we had a magical array that would shrink and grow to fit exactly what we needed in it. Kind of like, a magic suitcase or the Sisterhood of the Traveling Pans. We're talking about an object that would fit exactly the needs with no wasted space. Arrays are kind of like a suitcase that you buy at the store. You have a certain size, and if it's too small, you're going to have to go and buy a bigger suitcase and move all your stuff over. If it's too big, you can still use it, but you're wasting a lot of space. Array lists are the magic version of that. These are the ones that adapt to the size. Let's quickly remind ourselves about arrays. An array is defined something like this, with the type, the square brackets, and the variable name, so we've declared it. And then we initialize it by giving it some size, for example, 3. We can say nums 0 is equal to 10, and nums at 1 is equal to 20, and nums at 2 is equal to 30. Now, if we want to add more, we have to resize and copy everything over. That's sort of our reminder text here. Arrays are great for predictable size and ultra-fast indexing, but they can become very clunky as our data is growing. So what we see happening is if we do need a fourth spot, we're going to have to make that new array and copy all of our pieces over. Even if we use system.arrayCopy, it's still pretty clunky and expensive to copy our array. Now, ArrayList is going to give us this exact same indexed access, this random index structure, but it's going to manage the growth for us. It's actually really easy for us to create our own version of an array list if we ever wanted to try by making that object. Let's start by using the built-in one. Just like in our last set of videos, we had to add some import statements to bring in the file IO packages and libraries and classes. We need to bring in java.util.ArrayList to get access to the ArrayList class. Now, an array list can only hold objects, so we have to use the object version of int if we want to hold ints in it. We have to use the ArrayList integer. In order to declare our array list, we can say array list. You'll notice instead of using these square brackets, I'm using these triangle brackets, the chevrons, and then of course capital I integer, and then I can declare my variable. To initialize it, we still use our new keyword, and we need those angled brackets again and the round brackets. You can put the word integer in here as well, but it's not necessary. As long as this one has it on this side, it's fine. We've now declared an array list. By default, not that we would ever know, an array list has a capacity of 10. And after 10, the array list will start to change size. So let's just take a look at this very quickly. Actually, let's yeah, that's fine. Let's go ahead and add 10 to our list. Let's go ahead and add 20 to our list. And then let's try and print out some information. Get at 1 and list.size. All right, I'd like to sort of add a couple other lines here. We're going to add array index 1 needs to be nums at 1. Array list, it's getting long, is going to be this one here. Then we can have array nums at 1, whoops, array list. There we go. I'm going to do the same thing down here for the size. Array length is nums.length. Array list is list.size. Whoops. There we go. And then I'll just grab this line and copy it over just to make my life a little bit easier. Nums.length and list.size. We're going to run this, and then I'm just going to talk a little bit about those methods, but in very general terms, as I will be doing more detailed dive into them in future videos. So let's just go ahead and compile this. Oh, whoops, I'm missing a bracket right here. There we go. And there we go. So we can see that our array list indexing uses num with the square brackets 1, and our array list would use list.get at 1. We can see we get array 20 and array list 20. I added it here when I really didn't need to do that. There we go. That will need a space. That'll need a space. There, that'll look a little bit nicer. It's just kind of hard to read right now. Okay, so we can see them both right there. The two different ways of grabbing the index. We can grab by index without any issue at all. Now, the length function, when we want to find out how long an array is, we can say array.length, right, nums.length. For an array list, we actually use the size function, list.size. There's no real easy way for us to get the length of the array list, because really what we care about is the number of items that are inside of it right now. And so that's why we're using size there. And again, we'll talk a little bit more about that later. We can see that the array by default has 3 elements, or rather has a length of 3, and that's going to be true even if I remove one of them. So if I run this again, let me just clear this for clarity. You'll see that the array size, of course, as we expect, did not change size because it does measure the capacity. Dot length is the capacity, whereas list.size allows us to narrow in on the number of elements that are currently in there. So we have the same idea here, right? Zero-based indices, and we'll have access to a bunch of different methods. We've got adds and sets and gets and sizes, and we're going to dive deeper into them in future videos. For now, I want us to focus in on this right here, because this is new for us, these chevron or pointy brackets, also known as generics. And really what we're going to talk about is just the fact that what that is basically giving us is what's called type safety. This highlighted portion here, the chevrons with the integer inside, that part is a generic type. And basically what it's saying is our list can hold integers only. And this basically allows for us to ensure that we have no accidental mix-ups. What I mean is, it would be technically possible to design an array list to do something like this. Okay, this won't run because I have list and list, but just for argument's sake. We could do something like this, where we say list.add 10, list.add hello. Now, arrays would never have allowed us to mix and match in such a way, because we always defined it as like an int. In theory, we could restrict this in a similar way, or we could even open arrays in a similar way. But what we can see here is that without actually defining that type, that generic type, we can mix and match our data types within an array list. This is fine, and it's not the end of the world to even necessarily move between them, but it can be expensive to check for this and fix it while our code is running. So generics basically allow us to move errors that might occur in a situation like this from the runtime to compile time. When I add this here, it will basically not compile because hello is not going to be a type integer. This is going to save us time when our code is actually running and allow us to sort of ensure that we're following the expected type safety that we'd get with any other data type. Now, as I mentioned, we do have this initial capacity that's given to us when we write our code just like this. when we have the new array list and we have these round brackets right here, that's calling the default constructor. The default constructor of an array list, if you go and check the Oracle docs, will show you that you are going to get a capacity by default of 10. Because really, under the hood, an array list is actually just an array. And when it fills up, what it will do is create a bigger one, copy the items over for us, and continue. Now, the array will grow in exponential chunks for us, ultimately. So it often will double in size. By default, it starts at size 10. Once you've hit 10, if you need an 11th, it will grow to size 20, and then to size 40, and then to size 80, and so on and so forth. This, without really us getting too deep into the mathematics of it, basically the extra time it takes for us to do these occasional resizes end up being averaged over many ads. It's called being amortized, and we don't actually see a huge difference in the runtime, just because every once in a while we might have to do this doubling. But it's obviously much more convenient than handling it ourselves. All right, let's take a second to look at an example of the array list actually growing. Now, I have put together a program over here that is going to be a bit advanced and complicated, but we can take a quick look at it to understand a little bit of what's happening, and then I'm going to be able to actually show you what's happening in, air quotes, under the Java hood. So I'm making an array list here of integers, and I'm going to make it so that I can actually access sort of one of the data fields that are internal to the array list class. That's what I'm doing here. Now here I've got like an array, a for loop that's going to go 100 times, and I'm going to add to my array list each time. And right here, I'm going to go ahead and basically get that underlying array that's underneath the Java hood. That's what this element data actually is. And so then what I can do is I can show you the length of the array, which, as we know, is not the same thing as the size. The size is the number of elements. The length is going to actually be the length of the underlying array within the array list that we're working with here. And of course, if our capacity does not match the last capacity that we had, we are going to just print out that we've added X number of elements and our capacity has now increased. And then we will reset our last capacity so that this can keep going for up to 100 elements. Now, in order for my computer to even be allowed to run this, I have to run sort of like a special command as well. But we can go ahead and see that. We can see that after adding one element, our capacity is 10. And that's because that is our default, and our original last capacity was 0. And if you wanted to go check on the Oracle docs, you would be able to see the initial capacity would start as 10. We can see as soon as we hit that 11th element, it did increase by some amount. It increased to a size of 15. It didn't double, so I guess whatever version of Java I'm running right now, array list sizes are not doubling. They're using some other kind of formula to determine how many more spaces it needs to add. But we can actually see that happening, that once we hit that upper limit, the size increases. Here there was an increased size of 5, of 7, of 11, 5, 7, 11, 16, and then it really jumps 30, 20 something, and so on and so forth. My mental math is not going to be impressive here. Now I can, if I want, set my new array list, and within these brackets here, give a different default size. So I can set a default size right there, and I could even pick up these two lines and set my last capacity right there as well appropriately. That's a really weird place for me to have put that. Actually, I can put it right there. And then I can put this right here on that last capacity, and then this can just make new element data each time. And now what we'll actually see is I am going to give it an initial default capacity of 20. I need to recompile this file, and then I can run it. And now we'll see that I did have an initial capacity of 20, which means it didn't increase in size until 21. So I actually am able to visualize that with a little bit of Java magic. We can actually visualize what the heck is going on, which is kind of cool. So the main takeaway here is that arrays are fixed and array lists are indeed resizable. And with this idea of type-safe generics, which is this right here, we can make sure that our array lists behave exactly as an array without having to manage that growth on our own. What we also can see is that clearly underneath the Java hood, an array list is really just an array. Now we're actually going to use these array lists quite a bit, and so in my next video we're going to talk about adding, removing, updating elements and continue with the discussion of how can we use this powerful new tool to do some really cool stuff. I'll see you all in my next video.